Hello everyone, welcome to Join to Learn channel. So far we have covered 2 lectures in Signals and Systems playlist. The first one was like introduction to signals, what is meant by signal, and definition of signal and difference between signal and function. In the second lecture we discussed about classification of signals like continuous and discrete. In this lecture we are going to discuss about standard signals. This is very important. See, one thing you have to keep in mind that since we are discussing the first chapter, in any of the subject, the first chapter will be of the will be consisting of basics. So basics are I need not repeat this every time. Like basics are very important. If you don't understand the basics, and the upcoming chapters you will not understand, right? Without knowing the basics, without having perfect knowledge in basics. That is why every topic of the first chapter is very important. I will not repeat this from now on, so you should remember that each and every topic of the first chapter is very important. Now, among standard signals, the first signal which we have is, and the first one is unit step signal. So what is the definition of this signal and how this signal is drawn, and what is the mathematical form of this signal? Let us see. So how the let us know unit step signal is indicated as like this, u of t. This is the mathematical form, and its definition is like u of t is equals to 1 for t greater than 0, and it is 0 for t less than 0. So simply this is known as unit step signal. Now when we draw the graph of this unit step signal, how it will be, let us consider this as time axis. I already told you that whatever we discuss in this BTech course, we only discuss one-dimensional signals. In one-dimensional, particularly the independent variable will be time. Either it might be t, like continuous time, or it can be n. You can also write a unit step signal in terms of n. That we will see in the upcoming lectures. As of now, let this be t, and this is the u of t. So what is given in the definition? It is given as, let me change the color, 1 for t greater than 0. That means this is origin, right? Everyone should be knowing that this particular point in x and y axis, the intersection of x and y axis is known as origin. So whenever t greater than 0 indicates whenever it is positive values, u of t will be 1. So let us consider this as 1. What is 1? It is amplitude. And what is amplitude? We already discussed in the previous video. If anyone did not watch the previous one, please go and watch it, then come to this video. U of t is equals to 1 for t greater than 0, and it is 0 for t less than 0. Whatever it is in the left side of the origin, for all the values of t, for t less than 0, the amplitude of the unit step signal is 0. It means it will be indicated like that, like this. So there is a common myth among many of the students that u of t is equals to 1 for t is equals to 0. This is wrong. Definitely many of the students might be thinking, even if you see the graph also, you can observe that it is like 1 at instant of 0, at instant of time equals to 0. So but this is not true. See why? Because if we talk in particular, u of t is not defined where it is not defined at t is equals to 0. See why? See, because up to here the signal was it was not having any amplitude, it was 0, and when it is coming to 0, then there get a sudden rise of the amplitude, and then again the signal gets saturated at an amplitude of 1. So here before t equals to 0, that is t less than 0, the signal was continuous, it was having 0 amplitude. After t greater than 0, again the signal is continuous, it is having common amplitude or constant amplitude, or it is saturated. at the instant of 0 the signal got raised suddenly, like there is a kind of jerk, you can see. So that is why at 0 it is not equals to 1, it is increasing, that's it. You cannot say that as 1. So but this is just a what do you say, ideal case, ideal thing. I can say I can say this as theoretical explanation. But when it comes to practical thing, like when you have to solve the questions and all, there must be some value at t is equals to 0. So what is that value? It is given by a scientist known as Gibbs. It is also known as Gibbs phenomenon. So what did Gibbs say? That at t is equals to 0, u of t at t is equals to 0 is previous value, that is u of t for t less than 0 plus after the point of discontinuity. So this is known as point of discontinuity. Why? Because the continuous signal is getting discontinued at this particular point, again it is continued. So at t is equals to 0, u of t before point of discontinuity plus u of t after point of discontinuity divided by 2. So what is u of t before point of discontinuity? It is its amplitude is 0 plus after point of discontinuity is this 1. So it is equals to 1 by 2 u of t, right? This is the amplitude of the unit step signal at t is equals to 0. There is one more thing. See, so far we have discussed for amplitude 1 into u of t. If it is a into u of t, then how you would have drawn this? In this way, same, but the change is here amplitude would be a, not 1. That's the difference. Even here also, if it is a into u of t, here it would be a by 2 at t is equals to 0. This is about unit step signal. Don't think that the entire concept of unit step signal has been covered. No, it is not yet covered. You have to do many operations on this unit step signal, but we will do all those things after completion of the topics known as operations on signals. Till now this would be enough. The next standard signal which we have is, sorry, I hope it is visible now. What's the next signal? It is impulse signal. Impulse signal is very important. So how is impulse signal denoted as? Like it is del of t. So what is the definition of signal? Excuse me. Yeah, del of t is equals to infinity for t is equals to 0 and it is 0 elsewhere. And this is not the only definition. It is there are two definitions, and integral minus infinity to infinity del of t dt is equals to 1. Don't worry by saying the equations. This is very simple signal. Let me clarify. Let me explain you more deeply. See, what is this definition saying? Let us draw a graph of this impulse signal. So how it should be? It is like this is origin. So here what it is saying? It is saying that amplitude is infinity, right? And elsewhere the amplitude is 0. Okay, this is fine. Now what about this? What does Indic integration actually indicates? It is nothing but if you have studied the basic mathematics, differentiations and integration, what does this integration means? Integration is nothing but area under the function. Whatsoever the function would be present here, it is the area under this function. Integration means. So what is it saying? That for the entire interval the area of the impulse function should be 1. So here you can see, even if you consider the entire signal, entire interval, like from minus infinity to infinity, there is no signal at all. There is no amplitude of signal at all. The only instant of time where the amplitude is existing is origin, right? So the area under origin should be 1. So that is why what we will do is we will neglect this one, like amplitude is infinity. Practically we cannot do any of the equations. We cannot solve it. That is why what we will take, we will indicate with an arrow. Arrow is indicating that it is not the amplitude, it is area. So what is this one? This is 1. So this is known as impulse function. This is the graph of the impulse function, and this is the definition of the impulse function. So if this is a unit impulse function, like if you consider the amplitude as 2 into del of t, then how it should be? Only at the origin the area would be 2. Many of the people would be saying this as the amplitude of the signal is 2. Yeah, it is partially correct, but to be precise, this is not the amplitude, this is the area under this impulse function. Okay, that is the that's it about impulse function. What else should I tell you? There are a lot more things to discuss, particularly with respect to impulse function, but I cannot discuss it right now since you don't know about the operations. Okay, we will cover the remaining parts after covering the operations on signal. The third important standard signal is rectangular signal. A signal or function, you can call it in either of the ways. Rectangular signal. Okay, now let us come to definition. So how it would be? A into rect of t by tau is equals to this is A for mod t less than tau by 2, 0 elsewhere, or you can simply say mod t greater than tau by 2. This is nothing, elsewhere is same as mod t greater than tau by 2. So when you say mod t less than tau by 2, what does it means? It is minus tau by 2 less than t less than tau by 2. I know many of the people must be knowing how this has come from this expression. If some of you don't know about this, let me clarify you. So what is mod t plus or minus t? At least you must be knowing this. I can't help you if you don't know even this also. So first of all, I will consider mod t as t. So that implies mod t less than t by 2. Secondly, I will take mod t as minus t less than tau by 2. So what does this mean? T greater than minus tau by 2. Why it has changed the inequality sign? Because when you remove the minus, that is when you multiply minus on both sides, the inequality will get changed. This is the basic maths. So by combining these two, like mod t less than mod t by 2, t greater than minus mod t by 2, you will get this interval. Okay, so what is this saying now? This rectangular function excuse me, yeah, a rect of t by tau is equals to a for minus t by tau to minus tau by 2 to tau by 2. Let us draw the graph. This is the time axis. This is minus tau by 2 I will consider, and this I will consider as tau by 2. What's the amplitude at this point? It is a. Elsewhere it is 0. Okay, now so this is the rectangular function definition and graph. If you observe one thing, what is the area of this rectangle? So can anyone say the formula for area of rectangle? Area of rectangle is equals to, it is not a dot. Okay, area of rectangle is equals to length into breadth, right? That is the length here, it's a. This is the length, right? And this is the breadth. What is the breadth? Total breadth is here up to this it is tau by 2, up to this it is tau by 2. So total breadth is tau. So what is the area of rectangle? A into tau. So simply whenever you are given rectangular function as a into rect of t by tau, you should write area as a into the denominator or the time interval below t, a into tau. So this is about a normal general rectangular function. How about unit rectangular function? So unit rectangular function is nothing but a rectangular function or rectangular signal whose area is 1. So a into tau must be equals to 1. That how is this possible? When a is equals to 1 comma tau is equals to 1. That implies 1 into rect of t by 1 is equals to if I write like this, 1 for minus 1 by 2 less than t less than 1 by 2, sorry, and 0 elsewhere. So how it will be drawn? It will be drawn as like this. This is minus 1 by 2, this is 1 by 2, and this is 1. Okay, this is our rectangular function and unit rectangular signal or function. Now let us move to one more standard signal, that is nothing but fourth one. Which one should I teach you first after rectangular function? One second. Okay, I'll go with ramp function or ramp signal. Okay, so what is ramp signal definition? So k into r of t, it is denoted as r of t. K into r of t is equals to k for t greater than 0 and it is 0 for t less than 0. Let us draw the graph. How it will be? K, it is nothing but it is like t greater than 0. If I am saying this is t and this is r of t, that is ramp signal, it will be like this. See, you people must be having an idea about this, right? Y is equals to mx. How you will write this function as y is equals to mx as like this, right? And slope is m. Slope is equals to m. In the same way, when I am saying that k into r of t, this is similar to this y is equals to mx. How you can correlate is like r of t is equals to k into 1. This is nothing but k into r of t, that is k. This is not amplitude, this is known as slope. So what does this mean? So basically, what is a slope? Slope is nothing but change in y-axis divided by change in x-axis, right? Nobody would be having any doubt regarding this. So what do we have here as slope? We are having k divided by 1. So change in y, what is change in y? D r of t here, r divided by dt is equals to k by 1. So for each unit of time, so when time is changed by 1 second, or if it is in minutes, you can consider it at 1 minute. If it is in hours, you can consider it as in hours. I'm considering now time as seconds. So for each second of time, the y-axis should be increased by k units. So k units. This is known as slope. So for each 1 second of time, if the time is 2 seconds, like if it is 2 seconds, then what should be the amplitude? It should be 2k. That is when dr of t divided by dt is equals to 2k by 2. The slope would become k. So this is about ramp function. This is a general ramp function. When it is unit ramp function, the slope should be 1. It's simply r of t is equals to 1 for t greater than 0, 0 for t less than 0. So how the graph will be? You cannot say y is equals to mx is in the negative axis also. Why can't you draw it like in the negative part also? So see, because it is clearly said that in the definition itself, it is 0 for t less than 0. That is why I am not extending this line in the negative axis. Okay. And there is one more thing you should know, that this is not a discontinuous signal like unit step signal. How was the unit step signal? It was like here it was 0, then suddenly it was gone to 1, then again it got saturated. The 0 was here point of discontinuity because it has suddenly raised here. But ramp signal is not like that. It is slowly increasing. So this is continuous signal. There will not be any point of discontinuity. R of t at t is equals to 0 is equals to 0. Why? Here it is 0 clearly. It is not discontinuous. It at 0.1, its value is some 0.1k. It means the amplitude is defined at 0.1. Whereas here at 0.1, 0.2, 0.001, everywhere the amplitude is 1. Only at 0 it is 1 by 2. Okay, this is the difference between ramp signal and unit step signal. If I talk about the relationship between ramp and unit step signal, you can simply write ramp is equals to t into u of t. Now if anyone is having doubt like how did I write this, so you can consider like this. What is u of t? It is nothing but 1. This is u of t, this is t. And what is t? Simply t. It is like this, this is t. So if you multiply anything with now t would be also having negative part, because this is not I am simply talking about t. So how the graph of t will be? It will be like this, right? So if you multiply this thing with u of t, negative part at here we are having some amplitude at the negative parts, right, in the negative axis, whereas here you don't have anything. So 0 into anything into 0 is equals to the resultant. Let me draw here. This is t guys, this is t into u of t. You have to multiply with u of t. Here it is 1. So for the negative axis, what I am trying to say is it is 0. Anything into 0 would result in 0 only. So you won't be having anything in the negative axis. So anything into 1 is nothing but anything, like 0.1 into 1 is equals to 0.1. 0.8 into 1 is equals to 0.8. That is t into 1 is equals to t. It will become like this. So what is this one now? For the negative axis it is 0. For the positive axis it is t. This is nothing but r of t. That is what I am trying to tell you. That is r of t is equals to t into u of t. This is important relation. I think the length of video is becoming more. You people would lose interest if the length is getting extended. Okay, that is why I am stopping here. In the next video we are left with 3 more standard signals. We would cover those also. Then after that we will start the operations on signals. Till then, take care. We'll catch you up in the next video.